Any questions on the homework?
Like 4.
Is it?
51, 55, 59, 61. 51.
Oh, I don't have it on here. Chapter 3, right? 3 what? All right, which one? 51? All right. I think I'm about ready as soon as I find it. There we go. How you doing? Nice to see you. Every day. No, I just didn't have time to put this on the smart lesson like I wanted to. So, all right, tangent cubed to 2x, secant cubed to 2x. There are 3 sets of parentheses on this. One for the cube, one for the tangent, and same with the secant. There is one for the cube, one for the secant, one for the 2x. So we talked about if you wanted to use the notation for this, you could do like dy dv, dv du, du dx. Or if you just want to look at it this way, when you take the derivative of f of x, it would be the derivative of the cube function first. So you have a 3 and then a squared. I'm just doing tangent right now.
Is that equals?
Yeah, equals. That just equals 3. I'll rewrite that. Equals 3, and then you still have the tangent of 2x inside of that. Multiply it by the derivative of tangent, which is secant squared of 2x. Then multiply that by the derivative of 2x, which is 2. That's just the derivative of the tangent cubed of 2x. Then you subtract from that the derivative of secant cubed of 2x. So subtract. Same format. Secant 2x squared, secant 2x, tangent 2x. And then you got to multiply by the derivative of 2x, which is again 2. And then you kind of look for something common to write, so you don't have to write things twice. Both terms have a 3 and a 2, they have a 6. So I can take the 6 out of both of them. I can take the secant squared out of both of them and a tangent, right? So I'll go secant squared of 2x, tangent of 2x. I'm just doing that so I don't have to write them twice. That leaves me with the 6 is gone. Tangent 2x in the first term. And after that would be a secant 2x. Well, that's pretty nifty.
Is that minus or negative?
Minus. I mean, it's 2 parts. The original problem has subtraction in it. My subtraction just got carried over into the bottom row. Okay, I think that, I don't know, secant squared, tangent, looks close. Close enough for, is that what you're going to write down? What do you have? Oh, great. Rachel!
49.
Ooh, is it hard? 49. You can like get really fancy with this, but I don't think we will. I think we'll just kind of like power football through this. No, nothing fancy, just no trig identities. Of course, there are parentheses right here. So I have negative sine of 4w. That's the derivative of the numerator times the denominator minus cosine of 4w. Oh yeah, times derivative of the inside, which is 4. Thanks, Rachel. Derivative of 1 is 0. So I have a negative cosine 4w times 4. All over the denominator squared. Okay. Well, now you just kind of like figure things out. H prime of w equals negative 4 sine of 4w. I'm just going to multiply it out. It doesn't look that difficult. Plus sine squared of 4w plus cosine squared of 4w times 4. And that's a 4. There we go. Yeah, that's over 1 minus sine of 4w squared. That looks pretty good, doesn't it? Which is 1? It's close, it's not 1. You know on your note card that sine squared of theta plus cosine squared of theta is 1. There's 4's in front of it. So it equals 4. And through careful manipulation, I can write this as 4 minus 4 sine 4w, 1 minus sine 4w squared. Ergo 4 factored out. I don't see any light bulbs going off. So you only get 1. Yeah, you can divide that off. Nice! That's a good one. See if you're on your A game like that tomorrow, you'll be fine for the quiz. Yeah. Well, because nothing worth achieving is very easy.
But then it lowers my grade anymore. I'm not whining. I'm just.
She's not whining. We have talks like this all the time.
I don't know what you consider whining, but I don't want to take any risks.
Whining is like, I turn my face like, are you serious? You just said that. That's whining.
Because then we're going to use our note card more.
Anything else?
Don't we really just need a note card for the sine, the derivative?
Well, I don't know. What's the derivative of sine? There you go.
Tangent stuff.
What's the derivative of tangent?
I like to get
Okay, is that it? She does? She doesn't know.
Choose between 55, 59, or 65.
Oh, yeah.
I need. If you want to do all 3, that would be great.
No, I'm not going to do all 3.
You could do 2.
Which one, Jessica? She said
What were the numbers again?
59, 61.
59, 55, or 65.
Okay, I want you to do 59, 55, or 65.
So how about 59?
Just do the hardest.
59 is the easiest. All right, we'll do 55. All right, here's a known fact. This question is missed a lot because students do this. They write k of theta equals cosine of theta, or cosine of the square root of 3 minus 8 theta squared. The whole thing is actually squared. So the way to rewrite that is not with the radical right there, but to a half. 3 minus 8 theta to the half. Do not distribute this 2 to the half because that's an angle. The 2 is an exponent for the cosine of the ratio, not the angle. So you have to do the 2 first, k prime of theta equals 2 cosine 3 minus 8 theta to the 1/2 to the first. Next is the derivative of cosine, which is what? Negative sine. And your angle stays the same, 3 minus 8 theta to the 1/2 times the 1/2 times 3 minus 8 theta to the negative 1/2 times the derivative of 3 minus 8 theta, which is negative 8. It is. So, if you know nothing at all, which one, Jessica?
When you multiply by 1/2, is it sine of 3 minus 8 theta, or is it just 3 minus 8 theta?
3 minus 8 theta. So I took the derivative of 2 first. I took the derivative of the cosine. I took the derivative of the square root. I took the derivative of the linear function. Yep. The thing is, you can't combine the 2 and the 1/2. They aren't next to each other. Yep.
The half, derivative of the half, is that the cosine 3 minus 8?
Right there. That's the derivative of the half. This is the derivative of 3 minus 8 theta. This is the derivative of the cosine of the angle, and this is the derivative of the squared. Okay? So every part is accounted for. Now, if you're unsure of what to do, I mean, as Taylor just said, you work from the outside to the very inside when you're doing the chain rule. Like I said, the common mistake is thinking those are together, and they're actually not. They're actually, the cosine is in between the two. Okay? That prevents you from combining them. Order of operations, you go squared, cosine, then square root, then, you know. All right, that was fun. Would you like to try? Yeah, well, that was the first step. Well, I mean, you can take the half and the negative 8 and get negative 4. And then you got the negative 4 and you got the 2, so you got the negative 8. Oh yeah, the negative and the negative make it a positive, so that's gone. You got both of these in a square root, so you can combine square roots to put cosine 3 minus 8 theta, sine 3 minus 8 theta, because they're both in the same radical. Then you have a negative radical here, so you can put all over 3 minus 8 theta. The purpose of that question wasn't to simplify it. The purpose of that question was to see if you could do the chain rule 4 times and get the right answer. Okay? Yes? I mean, yeah, you need to leave it like this, which is fine. So you need to go just one more step. Yeah?
So if it's cosine root, all that times sine root of the angle, it's root over all of it?
Yeah, because they're both to the 1/2. Wait a minute. Yeah, it is just the angle. I misread my parentheses. Oh, it's fine. You do it in pencil. There. Swoop. Nice. Thanks, Rachel. Chase, how you doing? Glad you're back from your illness. 60. Are you really? I'm not going to have time for my lesson. That's all right. We'll make time. We'll just stay after.
Let's stay after. Hey, we gotta make a story.
We'll stay out. What does that look for?
I was getting ready to say, are you serious? But I didn't. I just
That's are you serious?
Yeah.
We didn't eat, we were playing.
Yeah. That hurt. That you don't want to stay and do calculus. Yeah. Yeah. I'll do that after I do some of my work. 65, you want to take a look at? Sure it will. I'm off of my game today. I can't really zoom in because I didn't. Oh, here it is. You have to do this on your tests. Probably the only reason I'm going to do this. Sure. I said find the equation of the tangent line, didn't I? All right. Is this point on or off the line? 1 plus 1 is 2 to the 5th is 32. It is on the line. So, sure it would. Find the equation of tangent line, normal line. So what's the derivative of this? Now on this, you do not have to simplify your derivative. That's not what it's after. Too many of you waste time simplifying something that's not your answer but work. You don't simplify work, you simplify your answers. Yeah, sometimes you do things in between, but like right here, I would not do any more than that. And I would put in 1 for, how what? Well, no, now you got to put in 1 for all the x's. And that gives you the slope of the tangent line. So the slope of the tangent line equals 5 times 2 to the 4th times 0? That can't be right.
That is.
Are you kidding me?
No.
What a dud of a problem.
You look very irritated.
I am. I just took the derivative of something. It came out to be 0. All right. Y minus 32 equals 0 times x minus 1. Why are you doing that? So I get the answer.
That's 0. Oh, kind of. Plus 32, so it would be 32.
Y equals 32 is the equation of my line, which means it's a horizontal line. So what's the equation of, what's the equation of the normal line? What is it? Y equals 32 is the equation of the tangent line. What's the equation of the normal line? That is the horizontal line. That is tangent. X equals 1 is the vertical line
What's the normal line thingy?
perpendicular to the tangent.
Is this normal?
This one is the normal,
I thought all you did
and this one is the tangent. You do, but the reciprocal of 0 is 1 over 0, which means it's undefined. The only equations that are undefined are x equals. Okay?
It's the reciprocal. Okay.
The reciprocal of the slope.
So 0.
Opposite reciprocal. So it's negative 1 over 0, which means x equals in this one. Find all the x coordinates on the tangent line, which the tangent line is horizontal. That's all of them. It's not? You said this equals 0 and solve? Oh, I said equal to this. 5 times x plus 1 over x to the 4th, 1 minus 1 over x squared. Solve that to equal 0. X plus 1 over x equals 0. That's when x... this little testing. There's not going to be anything there. So this factor is going to be a bust. Looks like this factor is going to be a bust. Maybe this one's got something. Plus or minus 1? Woohoo! I had a rough night last night with my fractions at Parkland. It was terrible. Yeah.
Can we just scratch it?
Yeah. Yeah, I guess. But you need exact values. Exact values for everything. I don't know, but Stephanie just gave Kaylee a look. You did. You went. It was a long roll.
That's not complaining.
I didn't say it was, but I'm like trying to figure out why. Because this one didn't go so bad. This is exciting. Which one? Let's see, there are multiple parts. You like the whole thing?
Get to the y minus 32.
Oh, that's the equation of the tangent line. I used the point. That was given. And the slope. That was given.
So the normal line is x equals 1. Is that what you said?
Yeah.
Why is that?
Because if I were to graph this out, let's say it looks something like this. Y equals 32 is through the point 1, 32, and it's tangent. Okay? If it's a horizontal line, and that came from the fact the slope equals 0, then the normal line has to be perpendicular. The only thing perpendicular to horizontal is a vertical line. And vertical lines have the equation x equals, and you use the coordinate to find that. That's the first time we've had a vertical line that's been normal. Yes?
So how would you find that it wasn't?
You would do the y minus y1 equals m times x minus x1. That would give me, well, I use a slope here for tangent from your derivative. I do the same equation, only I put the opposite reciprocal for the normal. Okay, so I use the same equation. That's why E said, well, isn't that negative 1 over 0? But it's undefined. So that's why it works.
So it's always 1 if it's
Then use the x coordinate.
Yeah, you always use the x coordinate if it's undefined.
so it's over the parentheses.
Mm-hmm.
Gotcha.
All right.
Yeah.
We got a lot of stuff to do today.
Are we gonna review for our
Well,
quiz
let's
time
go to
minutes?
75 today.
Am I going to review for my quiz? I don't know. It depends. What time is it?
5
minutes.
minutes. We already went to 7.
We have 5 minutes left?
Yeah. Times 10.
There we go.
You believed me yesterday when I did it.
Well, sure. Why wouldn't I?
I don't know. We had like 12 minutes left.
But we had, didn't we go over something?
Went over what?
Oh yeah, remember quiz.
No? We have more than one example left. We have the Stephanie Canfield example at the end. I love the last question. You ready? I'm going to call on Stephanie for it when we get there. She is. All right. Yeah, we did. Maybe there is no 70.
This isn't hard. I did it yesterday, dude.
Dude, I want to write it down.
Dude.
I did 66, just not 70.
I did 70 yesterday.
We did 70.
I did 7. No, I was getting ready to start it. Good. All right, on 70, it says find the first two derivatives. We talked about the chain rule twice. So Chase, what's the derivative of this?
2/3 and that's squared plus 4 negative 1/3 times 2s plus
Yeah. You take the derivative of the exponent, so it'd be 2/3 s squared plus 4 to the negative 1/3. Then you take the derivative of the inside, which is just 2s. That's not the challenge. The challenge is now the second derivative. How many variables do you see now in the first derivative? 2. And which rule are you going to use? Product rule. Within the product rule, you're going to have a chain rule and then a power rule or linear rule, however you want to look at it. But not to treat each one separately. You can combine them first if you like at 4/3 s or something. And now I can take the derivative of the first expression, 4/3 s. Riz, what's the derivative of 4/3 s? The derivative of the inside? What is it? I'll say, sorry. If you don't get it right, I'll call on Elizabeth. The 2/3 times the 2s makes 4/3 s. I mean, you don't have to, but. All right. Yeah, the derivative of 4/3 s is just 4/3. Woo-woo. So I take 4/3 times the second function, s squared plus 4 to the negative 1/3. Now I'm going to take the derivative of the second function. This, I'm going to use a chain rule on this second part. Because we never took the derivative of anything with an exponent. We took the derivative of s squared, but not s squared plus 4 to a power.
So whenever it's 2 power, we use the chain.
Yep.
Oh, I was mad because I forgot what part I wanted. I'm not mad at you.
So I'm going to take 4/3 s times the derivative of s squared plus 4 to the negative 1/3. So there's 4/3 s. And the derivative is just negative 1/3 s squared plus 4 to negative 4/3 times 2s. That's the second derivative. Times what? Right, this whole second part is the derivative of s squared plus 4 to the negative 1/3.
You add it to the different.
You multiply it, right. The product rule says if you have an f, g, you have f prime g plus f g prime. That's the product rule. And that's how it works on this one. This 4/3 s is the f function. This is the g function. That's how I look at it. Yeah.
So why is the first derivative? Why is the g part not? Why do we not find the derivative of that one?
We do back here.
Why don't you find the derivative of the first derivative?
Because I found the derivative of the leading function, which is 4/3 s. Okay? I mean, you can reverse this and do the g prime first if you want, but you only take the derivative of each part once. And you multiply it by the non-derivative of the other part. So far, so good? Now, the rest of this is just simplifying. It's algebra. And I made this comment last night in my pre-algebra class. They go, oh, do we have to simplify? I say, you got to learn to simplify everything. I'm not going to take the time right now to do this, but if you worked ahead, great. Here's what it turns out to be. I got it all the way down to that. Well, that's pretty impressive. It took me a while, but I got down to this far. And I said, you know what? I'm out of slides. I'm out of time. I'm tired. I'm hungry. I just want to be done with it.
You're always hungry.
Okay? I was. Yeah, I factored out a 4/3. No, I just combined these right here. Negative 2/3 s squared and s squared. I got 1/3.
S squared plus 12.
12 over 3 is 4.
So you just.
Yeah, I got a common denominator.
That's a lot in that.
Yeah? Oh. It's from algebra. Thanks, Vern. Yes, Abby. If that was a multiple choice answer on your test, yes. Nah, if you got it's anywhere in through here, that's fine. Yeah, that's fine. No. I never factor out of. Oh, because you always factor out the smallest. Well, 4/3 is the same thing as 12/9. Oh yeah, it is. Yeah, so I went the other way. Nice. Interesting move on my part. All right. I want to get to that fun question.
Number 74? That's what's next.
It does exist.
What number?
Oh, this one is all right. It's kind of a dud, but we'll do it. I got to get to the Stephanie Canfield question of the day.
Still have like 20 minutes.
I'm so excited because I was looking ahead, and we get to Rachel Graham's mining questions next section. Mining questions. All right, secant squared of 4t, a couple parentheses, one around the squared, one around the 4t. This is great practice for tomorrow. Find the second derivative. Yeah, the first derivative is easy. Just 2 secant 4t times secant 4t tangent 4t times 4. And then we go right down there, Matthew? Well, it's the squared first. The derivative of secant is secant tangent. And the derivative of 4t is 4. And that's the first derivative.
you can combine them.
Yeah, that'd be secant squared, and that'd be 8. So you have 8 secant squared tangent 4t. So you know with that.
Wait, how do you get square?
Because you're multiplying two things that are the same together. You can't change the angle, but you can square the trig function. Yeah,
Why does it get secant times tangent?
because it doesn't reduce to 1. It'd be sine over cosine squared.
But isn't it the derivative of 8 and 0?
No, you're thinking of something else, I think. If it would have went to 1, I would have done it. All right, ready for the next step? This is great. This is, if you can learn to do this, this is the next step in your college level math. When I take the derivative of the first expression, secant squared of 4t, I can use the fact that I know the derivative of secant squared 4t is all of this. Does that make sense? If I look at this expression, I'm going to take the derivative of for the product rule. You see how this is the function, f, and this is g? I'm just going to multiply the 8 by my answer. I already know the derivative of secant squared of 4t. It's the whole thing. So I don't really have to go through that part again. I can use that part. When you get into high-level math, you begin to pick up things like, I've already done this problem a couple pages earlier. I'm going to cite that answer like you would a paper in your work saying, I've already done this. Here's the answer, and you go on. You don't redo all the calculations if you recognize something from the past. So for this one, when I'm going to do it, and I wanted to do this problem, this is why, to show you that, I just put in 8 secant squared of 4t tangent 4t because I've just done the problem. That's the derivative of the first function f. Product rule says you take that times the derivative of tangent. It saves you a lot of time. If you have to grind all the math out every day at college, you wouldn't get it all done. Kind of like reading. You learn how to read efficiently. No. I said I'm just going to take 8 and multiply by my answer. I'm just going to take 8 and multiply by my answer.
So you don't take the derivative of 8?
No. I don't want to do a triple product rule.
So you just don't have to take the derivative of 8?
It's kind of like this. The limit, we had this rule of 8x squared as x approaches 2. The answer you would put in and get 4 times 8 is 32. That's the same thing as 8 times the limit as x approaches 2 of x squared. Okay? So I'm doing that with the 8. Oh, look at that. That was I love that thing. Anyway, not for today. I'll have to put it away. And then I take the derivative of tangent, and that becomes what? Secant squared 4t times 4. I think that's right. How you doing? And then I have the secant squared of 4t times 4. So this one's not bad if you learn to use your work in citing it, so to speak, in other work. Well, shoot, now I can factor out a secant squared and left. I can take out a 32 and all that other stuff. Yeah, you got a 64 in the first term and a 32 in the second. 64, yeah, I can take out 32. And that's the intermediate step, and then the final step. Ooh, I thought that was the... Is it? There we go. I guess I didn't factor out. I thought I was going to. Take out a secant squared and take out 32. I must got interrupted by my stats class. I should. That's okay. It's fine. Well, you got 32 secant squared times... That's overrated. I'll text it to you. Okay? I'll tweet it. Yeah.
But what if we don't have Twitter?
That's okay. Enough people do. It's fine. Ready? All right. I don't feel like doing it. Perfect.
We're only supposed to go to 30.
Here it is, the Graham question. There's the Graham question. Thank you. That's not orange. Now, looks can be either dead on or they can be deceiving. Could be. Look at all this information. Yeah. This is like an example of a great test question. Otherwise known as the Stephanie Canfield question.
You said this was the Rachel Graham.
No, we're getting to the Rachel Graham questions next week. The mining. She made little symbols, cute. All right. You have to ask her about it. You see this? It wants you to find the derivative of 0. So what's the derivative of the function u of x? What's the derivative of that? How do you find the derivative of u prime of x? I gave you that definition. I said, look, this is the textbook definition. Where are you going to take the derivative first? E, you're going to take the derivative of v first, w first, or x? V. So the derivative of u is the same thing as the derivative of v. Now, does w change when you take the derivative of v? No, it doesn't. So w doesn't change. And what are you going to do next? Take the derivative of w.
So this is like the same thing, just with all letters.
Right, same thing with all letters. Alex, what? The derivative of x with respect to x is 1. So you don't have to put the times 1. I mean, what's the derivative of x? 1. Dx over dx is the same numerator denominator, so it's 1. All right? The derivative of x with respect to x is dx over dx is just 1. So what is u prime of, oh, we want to put zeros in for all the x's, right? That's what it says, put zeros in for all the x's? No, you just put zeros in for all the x's. What does u prime of 0 equal? How'd you get that? It's in the given. U prime of 0 does equal 2. Yep. What about w of 0? What does that equal? Equals what? W 0 equals, yeah, 0. And what's w prime of 0? That's what you're looking for. So on the next step, we get 2 equals v prime of 0 times w prime of 0. What is v prime of 0 equal to? Negative 3. So that means w prime of 0 equals negative 2/3. That is, in a nutshell, how the chain rule works. And this is a great question because it looks difficult, but you apply the principles and just follow it through and you get your answer. And then you come up and say, I had no idea how I did that. You just follow the work. Actually, no, I think it's negative 2/3.
Oh, fine.
Yeah, you got to divide. Okay? Now,
5 minutes.
5 minutes? Seriously?
I promise.
Yes, yes.
Actually, like, you're the one more to do.
In the interest of fair play, in the interest of fair play,